Today we are doing lesson 6.5% of increase and decrease, day 2. Our I can statement for today, I can find the percent of increase and decrease. So we're going to start by just reviewing a couple of vocabulary terms before we get started. So we are looking at percent of change, and percent of change tells us how much something is increasing or decreasing using a percent number. And to find whatever that percent number is, we have to subtract to find our amount of change. So we subtract our two numbers to find the amount of change. So I'm going to write amount of change and then I'm going to put subtract here. And then we divide by the original number. That will tell us our decimal form, and then we need to change it into a percent either by multiplying by 100 or moving the decimal 2 places over. Percent of increase means our number is getting bigger. Percent of decrease means our number is getting smaller. So let's go ahead and take a look at our first problem. Find each percent of change. Round answers to the nearest tenth of a percent if necessary. I'm going to underline this just so we remember. 1/10 of a percent. So that means after we make it a decimal, after we make it a percent, we use 1 decimal place. Okay. First problem, 65 is decreased to 38. First thing we do is subtract. That tells us the amount of change. And we always subtract in a way that gives us a positive answer. So 65 minus 38 is 27. Then we need to divide by the original. Our original number is 65. It's the first one listed. That is what we are dividing by. So our amount of change, 27, divided by our original, 65. I get 0.4153846. Got to multiply by 100 or move that decimal 2 places over to the right to make it into percent form, 41 point. And then we look at the next number, 5. And we have to decide 41.5 or 41.6. And we decide that by looking at the number after the 5. The number after the 5 is a 3. If that second number is 5 or more, it rounds up. Otherwise, it stays the same. So because this was a 3, it becomes 41.5. If this was 41.56, then it would round up to 41.6. So our percent of decrease because our original number was going down, is about 41.5%. All right, go ahead and pause the video and try this next one on your own. Okay, let's check our answer. 41 is increased to 92. It's getting bigger. That's why it's an increase. We start by finding the amount of change. 92 minus 41 gives us an answer, 51. Our original number is the first one, 41. That's what we're going to divide by. 51 divided by 41, and it gives us 1.2439. Then we need to make it into a percent. So we can take that times 100, or move the decimal 2 places to the right. It's the same thing. We get 124 point. Then I look at my next number, 3, and the number behind it. And I have to decide 124.3 or 124.4. That 9 rounds the 3 up, so it's going to be 124.4%. All right, let's go ahead and take a look at our next problem here. A boutique buys hand-painted t-shirts for $12.60 each and sells them at a 110% increase in price. What is the selling price of the t-shirts? So we're going to be using the amount of increase to find a selling price for this problem. So the first thing we're going to do is find the amount of increase. So they're asking us to find 110% of $12.60. And we're trying to figure out is what number. So I could use a proportion or an equation. They have an equation set up here. 110% of means times means equals what is our variable. We need to take the percent, write in decimal form for an equation. That means moving the decimal 2 places to the left. So 110% is the same thing as 1.1 or 1 1/10. So then we do 1 1/10 and we multiply by $12.60 and we get $13.86. That's how much they want to earn every time they sell a t-shirt. They're not going to charge $13.86 because then they're only really making about $1. They want to charge $13.86 more than the price they paid. So to figure out what they're going to sell it for, we're going to add it to the original price. So they already paid $12.60, and then they're going to charge an extra $13.86 to the people they're selling it to, because that's how much extra they want to make. So that means our selling price, when we add those two numbers together, we get $26.46. That's our selling price. All right, let's go ahead and take a look at percent error. So percent error is a ratio that compares the inaccuracy of an estimate or the amount of error to the actual amount. So we're figuring out how off are you when you make a guess about a number. So percent error is similar to percent change. We start by finding the amount of error and we subtract to do that just like we do for percent change. But this time we're dividing by the actual amount. That's not the first number, it's whatever the actual is. And usually for these problems, the actual is listed second. So let's go ahead and take a look at our problem here. It says Alex wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it with chalk. Alex's estimate was 13.5 feet. The actual distance should be 15. So 15 minus 13.5 gives us 1.5. That's our amount of error. Okay, so now we're going to set up our ratio, our division problem. 1.5 divided by our actual, which is 15. I know the actual is 15 because it tells me this here. Actual distance should be 15 feet. When we divide 1.5 divided by 15, we get 0.1. We need to change that into a percent. We can do that by multiplying by 100 or moving the decimal 2 places to the right. Gives us 10%. I did have to add a placeholder 0 there. So Alex's percent error was 10%. He was 10% off in his guess. All right, here's our next problem. A contestant at the school fair asks students to guess the number of gumballs in the jar to win. Sarah guesses 300 gumballs. There were actually 400 in the jar. Find the percent error. Go ahead and pause the video and try this problem on your own. All right, let's check our answers. So we're going to start with subtraction, and again, we always subtract on these problems in a way that's going to give us a positive answer. So 400 minus 300 equals 100. She was off by 100 of the gumballs in her guess. Now I need the actual amount. That's going to be 400. Actually 400. So 100 over 400. That's our ratio. Okay, and now we are going to divide. So when we do 100 and we divide by 400, we get 25 hundredths. So I need that to be a percent form, which means I'm going to be moving my decimal 2 places over to the right, or I can multiply by 100, and that's going to tell me 25%. So Sarah's percent error is 25%.